Hi everyone. Today we're going to be looking at what is meant by the initial values and the zeros of a function. I think for the most part, today's class is going to end up being a review of these expressions. So, in your notebook please, today's subtitle, please put down initial values and zeros of a function. You will probably recall from grade 9, or even as far as back from grade 8, that the definition of the word initial value is basically the value of y when x equals 0. So let's get that expression down. Initial value, the value of y when x is 0. You may have also heard other teachers use the expression y-intercept. You actually find that expression in many textbooks. So please put down in your notes, aka, also known as y-intercept. To identify the initial value from a graph is actually very easy. All you have to do is basically look and see where the graph is cutting the y-axis. So let's get that down. To identify, we simply look at where the graph cuts the y-axis. If you don't have a graph and are simply given a function, then to calculate the initial value, all you have to do is the following. Let's get it down in your notes. All you have to do is set x to 0 and isolate the y value. And that's basically all there is to what is meant by the initial value of a function. Now, let's look at what the zero of a function means. It's pretty much the complete opposite of what initial value means. The definition of the zero is the following. It is the value of x when y is 0. As you may have heard other teachers put it, you will also be able to call the 0 the x-intercept. So please put that definition down also. The 0, also known as, aka, the x-intercept. You will also see this word in many textbooks. If you are given a graph and asked to identify the 0, or zeros, there could be more than one, then it's actually very easy. Visually, all you're looking for is the following. To identify, you're looking for where the graph cuts the x-axis, and it can cut the x-axis in more than one location. If you are not given the graph, and all you're given is the function, then to calculate the 0 or zeros, all you have to do is the following. Set y to 0 and isolate your x. And that's all there is to the definition of 0. So as you can see, the initial value and the zeros are pretty much the exact opposite. One is where it cuts the y-axis, and the other, the 0, is where it cuts the x-axis. Now let's do a few examples. So I would like you to put EX. So first example, I'd like you to calculate the following. I want you to determine the initial value and the zeros of the function minus 350x plus 15,000. So, here's how I expect your work to look like. Let's do the initial value first. I personally think this is always the easiest one. So, initial value, to calculate it, all you have to do is plug in 0 into the x. So let's do it. Minus 350 times 0 plus 15,000. And you will get that the initial value for this function is y equals 15,000. Done. Let's calculate the 0 or zeros. There could be more than one. So to calculate the zeros, this time we have to set y to 0 and isolate the x. So let's do it. 0 equals minus 350 x plus 15,000. So go ahead, let's isolate the x. So I'm going to put the x on the left side. And one more step. I find that the x equals 42.857. So in this particular function, there exists only one zero. Alright, let's try another example. Like you put ex. I would like you to take a moment and draw the following graph. Go ahead, pause the video, and draw it now. Alright, let's take a look at visually identifying the initial value and the zero. So don't forget, the initial value is the value of y when x is 0. So essentially, we're looking for where the graph cuts the y-axis. And as you can see, very easy to identify. It cuts the y-axis at y equals 1. So let's put that one down. Now for the 0 or zeros, there could be more than one sometimes. In this particular case, it's very easy to see that there's only one 0. Where does it cut the x-axis? It cuts it at x equals 2. So let's put that down. There we go. That's all there is to it. Visual identification of the initial value and the zeros is extremely easy. Let's take a look at another type of graph which we'll be studying very, very soon. So I'd like you to put example. I would like you to pause the video and draw this particular graph. It's a parabola. So go ahead, pause, and draw it now. Alright, so let's again visually identify the initial value and the 0 or zeros. So the initial value, where does it cut the y-axis? If you guessed y equals minus 2, then you're absolutely right. So let's put it down. Alright, let's visually identify the zeros. In this particular case, I hope that everyone can see easily that this graph has two zeros. It cuts the x-axis in two places, at minus 1 and at positive 1. So let's get that down. So all we have to do is write x equals minus 1 and positive 1. And that's all there is to this example. Let's do one last visual identification example. So I would like you to get the following graph. Put example down. I'd like you to take a moment to get this particular graph down. Go ahead, pause the video, and draw it now. Alright, this one is a bit of an interesting one. So, from our visual identification, I hope everyone can tell that the initial value is y equals 2. So let's put that one down. Now the zeros. Notice that this is a constant function. It's a flat line, and as such, this particular graph will never touch the x-axis. So we can say that there are no zeros. You can simply write this. Zeros equals none. And that's good enough for me. Alright, that's all there is to initial value and zeros of a function.